I'd like to share some feedback we got on how to leverage blockchain technology and the cloud to deal with territorial control of data. So there's something related to the first presentation, and it's interesting to see both presentations. First, I'd like to start to give a definition of infrastructure, as I will use this term many times later. So an infrastructure is a set of configured servers with an architecture that makes it possible for your applications to be online even during peaks and lows. So just to make sure we understand each other when I use the term later. A little bit of history. The evolution of infrastructure for the last decades. If we go back to the 1990s, sys administrators who had to configure the servers so your application is available, had to deal with physical data centers. So they had to go in premises and to plug wires, to configure everything manually. So it was very, it was not agile like what we have now. And during the years 2000, virtual machines appeared. So with virtual machine, it was easier for system administrators because they were able to create new virtual machines, to configure more easily all the software. So they still relied on physical data center at that time, but it was a step further. And around 2010, maybe 2006 or 7 with Amazon. I know there is somebody from Amazon Web Service in the room, so I will try not to say wrong things about this. Amazon Web Services, Amazon at that time, had a problem to deal with. They spent millions of euros for the maintenance of their data centers with their e-commerce activity. So Jeff Bezos asked, how could we leverage all the computing power that are underused? And so they invented a new concept which consists in providing computing power on demand, and we call that infrastructure as a service. So infrastructure as a service is simply the capacity to instantiate, to create a new server using an API. So basically, the work of system administrators is quite the same as before, but the main difference is that they don't have to go to physical data center because they can do their job from the Starbucks or anywhere. So they just will instantiate the server as needed, just from their computer, wherever they are. And there is a big change in the area around the years 2015. Docker, which is a unicorn, a very well-known company in the area, created a product that has revolutionized the way of packaging software for software developers. I won't dive into details, of course, but just to be brief, Docker is a way for software developers to package their software. And so when your software works well on your container, you are sure that it's going to be working well on any other environment. In a short description, something as a service. You have all heard, I think, of something as a service, like software as a service, platform as a service, infrastructure as a service. I would like just to explain the differences because sometimes it's confusing and people don't really understand the differences. Software as a service is just a way to use a software so you don't have to install it on your own machine and you just use it and it's somewhere in the cloud, so you are using the software via Internet. Infrastructure as a service is what I explained just before, and that was brought by Amazon Web Services. It's just the capacity to have your own server on the cloud. So it's at a lower level, and it's more for system administrator or people who want to just instantiate a server. Platform as a service is more technical. It's more for the software developers. Platform as a service is just a mix. It's sort of infrastructure as a service, but at a higher level because, for example, the developer can upload his software in a specific language, and the platform will deal with. Will make sure that all is working well on top of an infrastructure. So one of the implications of infrastructure as a service, there are many things that I often hear, and people say, oh yes, but the problem with infrastructure as a service is that we have a provider dependency. So and there is a topic about data location. This was a problem a few years ago, but now all EIS providers have data centers all around the world, so it's less a problem than before, but I will explain it later. It's still complex to configure. It doesn't mean it's still complex, it's the same as before. You must be a system administrator if you want to configure a complex infrastructure. It has not changed. The only things that changed is that you stop dealing with hardware issues, which is a big improvement because hardware issues are very hard to solve. There is a significant drop of cost as you just pay as you go by the minute of use, depending on the use you have for your application. Now I'd like to speak about territorial control of data and regulations constraints. So there's been an increasing trend of regulation on data protection and data localization all around the world. So the most famous law you have probably heard about is GDPR. It's been explained just before, so I won't repeat it. And there is another thing that we don't really talk about, but it's quite complex also. That it's data residency. It's the same as data localization or territorial control of data. So this concept where business is located, for example, or sometimes it can make mandatory that personal data about your customers must be located in the country where resides the individual or the company. And sometimes it can be related to the activities if you are in the healthcare industry or in finance. So it's a nightmare because it brings more questions and answers, and there are things that are not quite clear even for the regulations authorities. But for example, if you need to store the data of your customer in the country he resides, if you have customers all around the world, it can be very complicated. And the origin of data residency law, so Brazil was the first country where data localization laws were applied. But it's in 2013 when Edward Snowden revealed that counterterrorism surveillance programs in the United States was looking at data, personal data of all data collected in the United States. So more and more countries wanted to put in place some regulations to make it mandatory to store some data in the country for some different situations. There are many different laws, and the very complicated thing is that you cannot know all the laws of all countries. The European Union in 2017 wanted to create a new data localization rule, but it has not been voted yet. But we could expect that it's going to come in the next years. So currently, it's already applied in the European Union, you have more than 50 data localization restrictions in national laws around the EU. For example, you have the Protection Act in the UK, in Canada, not in the EU, but you have the Privacy Act in Canada, and many, many other laws. Of course, we have the GDPR, which is not related to data localization. It's other things, but it has consequences for system administrators, of course. So don't ask me the details of this law. I'm not a lawyer, but I'm just here to explain how we dealt with some of these constraints in terms of infrastructure. So I think one of the most important implications of the new regulations and of course of GDPR is that, in particular for big companies, but not only, it depends on where are your customers, lawyers and IT must work together. And the architecture of infrastructures must be adapted accordingly. And the changes can be very expensive, and sometimes we don't realize how expensive it can be. So I will share how we try to solve these things. So SQUARESCALE Vision, SQUARESCALE, so the company I co-founded 3 years ago, which is a subsidiary of Sogelis, which is a company I founded 10 years ago. So our vision is to make cutting-edge infrastructure technologies accessible to every company. So instead of infrastructure, I could have used the word clustering technologies, but it depends on the audience if it's technical or not. So we have created another something as a service term because we do it differently. We call it cloud native infrastructure as a service. I'd like to share with you an experience we have seen many times with customers, which I call the media effect. So it can apply for big companies as well as startups. The example I would like to give is from startups we worked with. So some startups, sometimes they have just started their website, their application, and they have just small servers because they don't realize how important it is to scale when they have peak and load. And so they are very proud because they have been accepted. They were accepted to, they got an interview on television, and at time of broadcast, everybody is connecting to the server, so the server goes down because it's not able to scale. And so it's a catastrophe for the startup. And this happens very often. So what we did, the SQUARESCALE platform, it's just a platform which is on top of infrastructure as a service provider such as Amazon. So we support currently Amazon Web Services. And we are able to create your own infrastructure in just a few clicks, and it's your own dedicated infrastructure in cluster. You don't need to know how it works. And in 5 minutes, it's going to be created, and it would have taken several weeks or several months to very highly skilled sysadmins to do the same. So I mean a platform, an infrastructure that is able to scale. If, for example, you have just a little traffic, so you will pay something like 300 euros per month. And if you know that you are going to have a peak in your traffic because it's Christmas or it's Black Friday, so you can increase the computing power, the number of node of your cluster, very easily. So it's accessible on one click, so you don't need any more sysadmin skills. It's intended for developers. Developers are going to create the software, but there are two different activities in the software industry. You have software developers, people who create the software, and you have system administrators who are going to put the application from software developers into production. So now, developers, as far as if they provide you, if they have some containers for their application, or either a container or a Java application, they can just put it into production in one click. So with SQUARESCALE, the customer can very easily scale his application. So I won't dive into details because maybe it's too technical, but you can scale vertically or horizontally. So you can increase the power of the nodes of your cluster or the number of nodes. The interesting thing is that you can select an infrastructure scheme. So the first thing, which is currently available with Amazon currently, you can just create your own infrastructure, and the simpler, the easier scheme is a cloud with the choice of your infrastructure provider. So currently we support only Amazon Web Services, and when you click it, you have a cluster with different nodes that can run your Docker services. You have a load balancer, you have a database server, which you can choose, MySQL, Postgres, MariaDB, etc. You have firewall, etc. And of course, you can choose the region where your infrastructure is located. The second scheme we have in the lab, it's not yet, it should be released by the end of the year, but you can choose a multi-region single provider infrastructure. So this means basically that your infrastructure is split between, for example, Amazon has some data center in Ireland, in Paris, in the United States, in Asia, etc. So you can say, okay, I will split it in different regions. If there is any problem on any infrastructure, it will be redirected, the traffic will be redirected to the nearest infrastructure, working infrastructure. We have another very, very complex scheme, which is a multi-region, multi-cloud, multi-master. So it's still quite easy to use for the customer, but it's quite complex to put in place. And this scheme, actually, it already exists. Some companies have this kind of very high, with high availability infrastructure, but it's very hard to put in place, and it can cost millions of euros to put in place. So this consists in distributing your infrastructure between, for example, Amazon Web Service in the US, Google Cloud in Europe, Packet or OTH or every provider you want, and you just say to the application, I want to run my application, and even which can be split in different microservices. And so if there is any problem with one provider, it will always work because we make sure that the load is distributed to the nearest working infrastructure. And if I want to speak about territorial control of data, we have created an API and a mechanism that can allow very easily the choice of having a selective synchronization of data. Just imagine that the laws you must comply with tell you that you need to have the tables about your personal data of your customers living in Europe, and some other data of your customers that need to be stored in the United States needs to be in the US. So if you need to do it manually, it's very, very expensive. So with just one click, with an API or via the website interface or with a command line interface, you can select, you can just say, okay, my infrastructure is split between different infrastructure, different providers, and I want that the tables of my database server, which have this criteria that you are going to define. According to the criteria, it will be synchronized only in Europe or in the United States. So it's really easy to say in a few minutes how your infrastructure will make sure you comply with the law. One of our goals is to go towards 100% SLA availability. So I first need to explain what SLA means. SLA is service level agreements, and usually when you use any provider, usually if you have 99.9% of SLA, it means that 99.9% of the time they make sure, they pretend that your infrastructure will work well. But sometimes they have some problem. It's unavoidable. For example, 3 months ago in France, the OVH company has had many problems, and for 1 or 2 days, 5,000 servers were down. So it happens sometimes. It happens to every provider, and you cannot reach the same level with your own data center, for sure. So the last decimal are very expensive to reach, and if you want to be close to 100%, you really need to have a very complex infrastructure. So of course, what I'm talking now is not for small companies. It's for companies who can lose a lot of money if there is just 1 minute of downtime. The very high availability option, it's possible, but it's reserved only to big companies and companies like Facebook, Amazon, Netflix, etc. So what the schemes I showed you just before makes it possible to deal with 100% availability in theory, because it depends. If you have every provider failing at the same time, of course we couldn't do it, but it's unlikely. So we have created a decentralized monitoring system. I will just explain briefly, just a question. Does everybody know what blockchain is? Who doesn't know? Everybody knows? Oh, okay. So very briefly, because I could speak about that for 10 hours. Blockchain is the technology behind the Bitcoin, so the crypto money. Blockchain is a way to make sure that the critical data cannot be corrupted. So the data will be decentralized and distributed among many nodes, and there is complex cryptographic things that make sure that once the data is inserted into the blockchain, you cannot corrupt it. So it's a good way to ensure that the data is right. So one of the problems when I speak about SLA, if your provider told him, no, I was available, but as a customer, you said, no, you weren't. I had a problem. So it's the provider against the customer. So there is a problem of trust. So the solution we have put in place, it's a decentralized monitoring solution. So we have many contributors all around the world. They just install a small piece of software, for example, a Promise extension, and they get some money for doing this, and they will receive some requests to monitor the availability of one website, for example. So is it every 5 minutes, for example, I will check if your application is online. And you will have thousands of users all around the world, and there will be a consensus. The algorithm is complex, I will explain it there, but the data is written on the blockchain. So if there is a misunderstanding between the provider and the customer, you can just check the blockchain. Okay, was my solution online at that time on that day? So it's a good way for us to measure if we are able to provide this availability. But the availability is provided by the IaaS provider we use, because we are not provider ourselves. Okay, so this is our feedback. If I just want to give you a conclusion about what I said, I realize that if you are not technical, maybe some terms I used are quite hard to understand. But the conclusion is that you really must be aware of the impact of regulation on your business according to the geographies you are involved in. So don't hesitate to share information between lawyers and IT. And if you have customers all around the world, it can be a big issue because the fines are very, very high. So thank you very much.